Hi, in this video we're going to take a look at an AQA past paper question on the mole, specifically the ideal gas equation. If you want to have a go at it, you'll need a data sheet and a calculator. So take a look at the question. We can see that it's worth 4 marks, so really important that you show your working out thoroughly. It's an ideal gas equation question because we can see that we are working out the volume of a vapour, i.e. the volume of a gas. Also, we can see that it's 185 degrees Celsius, so this is not room temperature and pressure, so we have to use the ideal gas equation. There's the ideal gas equation. We can get these variables from the data in the question, however, it is essential that you know which unit to use and how to convert between them. Always a good idea to make the thing that you're trying to work out the subject and do that algebraically. We also need to work out the amount of iodine, so we're going to need to use an equation to calculate that. So we're given our pressure in kilopascals, so to convert that to pascals, which is what we need, we multiply by 1000 or times 10 to the power of 3. We use SI units when we're dealing with the ideal gas equation. The gas constant R is given to us in the question, so use what you're given in the question, 8.31 for the gas constant. And the temperature is given in the question in degrees Celsius. We had to convert that to Kelvin. So to convert from degrees Celsius to Kelvin, we had to add 273. There's the rearrangement of the ideal gas equation with V as the subject. To work out the amount of iodine, the moles of iodine, we have to use the equation number of moles is equal to mass divided by molar mass. You have to remember, of course, that iodine is diatomic. It exists as molecules of I2. So we need to work out the relative molecular mass of iodine by multiplying the atomic mass by 2. So that gives us 5.00 divided by 253.8. The amount of iodine works out to be 0.0197 moles. I've included a couple of extra significant figures there, not that I needed to, but just to remind ourselves if we need a final answer to 3 significant figures, we need to retain a couple of extra in the question. Putting those values into the ideal gas equation gives us a volume of 7.50 times 10 to the minus 4 meters cubed. If we look at the question though, we're required to give the volume in centimeters cubed. To convert from centimeters cubed, or to convert from meters cubed to centimeters cubed, multiplied by 1,000,000, so that works out at 750 centimeters cubed. Okay, so just to summarize, when you're doing any ideal gas equation question, it's essential that you know the ideal gas equation, PV is equal to nRT, and how to make any of those terms the subject. You also need to know what those terms are, so pressure, volume of gas, amount of substance, the ideal gas constant and temperature, and you also need to know the appropriate units to use. As well as knowing which units to use, you have to know how to convert between units. So to get from kilopascals to pascals, multiply by 1000. To go in the opposite direction, divide by 1000. Meters cubed to decimeters cubed, multiply by 1000. Decimeters cubed to centimeters cubed, multiply by 1000. And obviously if you go in the opposite direction, you would divide. To get from degrees Celsius to Kelvin, you need to add 273.